Hi all, welcome to Pi Networks. So in this session, we will discuss problems related to op-amp. So the first question is, find the resistor value of an unknown resistor from the given circuit. What are the key observations that you can infer from this circuit? Here, the positive terminal, that is the non-inverting terminal of the op-amp is grounded and the output voltage is given as 7 volt and we have three inputs, that is 4 volt, 2 volt and 3 volt, which is applied to the inverting terminal of the op-amp using three resistors, that is 2 ohm, R and 4 ohm, in which this is the unknown resistor we have to find. And one more point that we can infer from this circuit is there is a feedback from the output voltage again to the inverting terminal through 12 ohm resistor. Okay. So this type of circuit comes under the category of summing amplifier with inverting configuration. So why it is coming under the inverting configuration? Because the inputs minus 4 volt, 2 volt and 3 volt are applied to the inverting terminal of the op-amp. Okay. So to solve this kind of questions, we need to use the concept of nodal analysis. Okay. So in order to proceed with the nodal analysis, let us take this node as point A. So how can you write the nodal equation then? It becomes VA minus 4 by 2 plus VA minus 2 by R plus VA minus 3 by 4 plus VA minus 7 by 12, which is equal to 0. Okay. So what about VA? What is the value or voltage at point A? For that, we can apply the concept of virtual ground. So what is virtual ground? Why we are able to apply the concept of virtual ground here? Here, what about the positive terminal voltage? V plus, that is voltage at the positive terminal, which is grounded. So grounded means it becomes 0 volt. And here, what type of feedback is applied? The feedback applied is here is negative feedback. So with these 2 points, we can use virtual ground concept and say VA is equal to 0 volt, which is same as that voltage at the positive terminal. Okay. So now what we have to do is substitute VA is equal to 0 volt. In the equation, we can replace VA with 0 volt. Now rearrange the equation and the equation becomes 4 by 2 minus 2 by R minus 3 by 4 minus 7 by 12 is equal to 0. We can make the necessary simplifications. So this becomes 2 and we can rewrite it as 2 is equal to 2 by R plus 3 by 4 plus 7 by 12 and make the denominators common. 2 by R plus, so this becomes 9 plus 7 by 12, which can be again modified as 16 by 12, which is equal to 4 by 3. Now, the equation can be modified as 2 minus 4 by 3 is equal to 2 by R. So, on modification, we can rewrite it as 6 minus 4 by 3, which is equal to 2 by R, and this becomes 2 by 3 equal to 2 by 3. So this will cancel, and the final answer we will get as R is equal to 3 ohm. I hope this is clear to everyone. We are finding the R value using nodal equation as well as applying the concept of virtual ground. Okay, so let's move on to the next question. The second question is, design a non-inverting amplifier circuit with a gain of 2. And the given conditions are V out is equal to 10 volt and the current through the feedback path, and this is the feedback path, and that is equal to 10 microampere. So this circuit comes under which configuration? It is in the non-inverting configuration. Why? Because here we are applying the input Vi to the positive terminal. Since we are applying it to the positive terminal, we can say that this circuit is in non-inverting configuration. And for a general non-inverting configured op-amp, what is the gain equation? We can write the gain equation as AV is equal to 1 plus RF by R1. Okay. And what about the general gain equation? We can also write as the general equation for gain, AV is equal to V out by V in. Now we have to use these two equations to design a non-inverting amplifier circuit. So designing a non-inverting amplifier circuit means you have to find the value of R1 and RF. That is actually meant in this question. So let's proceed. So in this question, V out is given as 10 volt and gain is given as 2. So we can apply to the general equation to find the V in, that is AV is equal to V out by V in. The gain is directly given as 2 and V out is given in the question as 10, and from this we can find VI as VI equal to 5 volt. Okay, so now we get VI value, that is the input voltage. We are aware of the input voltage as 5 volt. Next, what we can do is, what about this node A? So here, what is voltage at VA? Here we are applying the concept of virtual short. So with the concept of virtual short, here also we are able to apply the concept virtual short because of the negative feedback in the given configured circuit. Okay. So VA becomes same as that of VIN applying this concept. So we can write VA as VI, which is equal to 5 volt. Now, what is the current flowing through the feedback resistor RF? The current here is given directly in the question as 10 microampere. So how can you frame the equation for that current? We can write it as V out minus VA by RF is equal to 10 microampere. Okay, that is a voltage difference between the two nodes divided by the resistor that will be equal to the current flowing through that path. And that is V out minus VA by RF is equal to 10 microampere. Now substitute the values which we have now, and that becomes, we know what is V out. It is directly given in the question as 10 volt minus VI. Just now we have found out VI, then that is 5 volt. And what about RF? It is unknown. And next, it is equal to 10 microampere. So what is this? It becomes, this is equal to, this 10 minus 5 becomes 5. So we can rewrite and say RF will be equal to 5 by 10 micro, and that is equal to 0.5 mega ohms. Okay, so now we get the answer for feedback resistance RF, which is equal to 0.5 mega ohms. So what is the next step? Next, we need to find R1. Okay, for that, what we have to do is we should use the gain equation of non-inverting op amp. And what is the gain equation of non-inverting op amp? It is AV equal to 1 plus RF by R1. And we know the values of AV, which is equal to 2, and RF, which is equal to 0.5 mega ohm. Substitute and see what we are getting. So it becomes 1 plus RF is zero point 0.5 mega ohm by R1 is equal to 2. So on rearranging, we can write mega ohm R1 is equal to 1. Thus, we can conclude that R1 value is same as that of zero point 0.5 mega ohm. So the final designing part is we have an op amp with input voltage as 5 volt, output voltage as 10 volt, and the feedback resistance as zero point 0.5 mega ohms and R1 as zero point 0.5 mega ohms, and this is ground. So this is a final designed non-inverting amplifier. I hope both these questions are clear to you. We have used the concept of virtual ground, nodal analysis, and the current flowing through a path between two nodes. Okay, so these are the three main concepts which we have applied to find these two questions. I hope this video is useful to you. Follow Pi Networks for more videos. Thank you.